Hi folks, this video is designed to get you ready for the homework for section 6.2. So we're going to run through some examples that we were trying to get done in class but maybe didn't have time for. Some of you may have seen some of these examples, so certainly you're welcome to fast forward ahead if you need to see other things from towards the end of the video. I'll try to keep it from taking too long, so let's get started. We're looking at some of the problems that are on the class example sheet for section 6.2, and so you may see this is looks like number 2 from that class example sheet, and this is getting to coming back to that theme of does the order in which transformations occur, does that matter? And so we want to see if there's a difference between these two functions here. We have p of x, which is 4 times j of x minus 3, and then q of x, which is 4 times the quantity j of x minus 3. So hopefully you're recognizing that there is a vertical stretch, right, by a factor of 4, and a vertical shift, looks like down 3, and that's occurring in both. But what is the order in which they happen? So just wanted to write down list what those transformations are here for p of x and then q of x. Why don't you pause the video and give that a shot, and then you check and see if you got what I got. See if this is what you got. Okay, so did you get that we have the vertical stretch by a factor of, whoops, I wrote 2, that should be a 4 there, for p of x, and then we shifted down 3 units, right? And for q of x, right, we're going to do the opposite. We just follow our order of operations. We got to do the shift first and then this vertical stretch. So let's see, let me see if I can fix a couple things. This should be by a factor of 4, and then we'll just draw little arrows so that the stretch comes second and the shift comes first for q of x. So now the question is, does that make these two functions the same or different? And there's some different ways you can look at that. One of which might be to think about an actual graph and whether the graph would give you something different. But it's actually fairly easy to see that these are not different if we just do the algebra, right? We can compare these two functions if we get rid of the parentheses over here. And so it's pretty easy to see that q of x is going to be, yes, 4 times j of x minus 12. I realize, by the way, I should have put a j here. It's not f that we're changing, it's j. Alright, so certainly there's a difference here. And now, what transformations of shifts and or stretches would take you from p's graph to q's? I think we can see that if we're only shifting down 3, while we're shifting, down 12, so like compare this formula here with this one down here, then we would need to shift p another 9 units down to get q, right? So we could write the following. Yeah, p of x minus 9 equals q of x. Alright, so just to check this out, let's look at some graphs. So here we can see I've graphed this blue graph is just y equals x squared. Alright, and so that's going to be our basic graph, and now let's do the stretch by a factor of 4 and then down 3. So if we do that, we get the red graph, right? You can kind of see it's stretched vertically, and then we're shifting down 3, so its vertex is at 0, 3. Now, had we shifted first, here, let me draw that graph in. So had we shifted first, we would have ended up with this black graph, right, down 3 units and kind of even with the blue graph. And then when we stretch it, should make sense, we're going to multiply by 4, and negative 3 times 4 would give us negative 12 down here. So I can't really point to it here, but anyway, you get the idea. And so they are definitely different graphs, and you can also see that if we were to shift the red graph down 9, right? That's like our p of x. We would have the black graph, which is our q of x. All right, good stuff. Let's move on to the next example on the sheet. Number 3 is maybe one of the harder things to do, where you're given a graph here, And I'm telling you that it's a transformation of just the basic graph 2 to the x, and you have to figure out, all right, what's the new formula for this function? This function's g, right? We're starting with f being 2 to the x. And how do we get g, just by looking for transformations? So let's just sketch some preliminary graphs first, okay? We'll get started here. I should say we'll get started here by sketching, let's sketch 2 to the x, all right? So if you remember with exponential functions, whoops, let me get back over to my finger here. If you'll remember, we do have certain features, right? We know it's going to go through 0, 1, since 1 is your a term, and it's got to go through 1, 2, and then you can of course plot a couple other points like 2, 4, and 3, 8. And it does have to have this horizontal asymptote of y equals 0. So there's our graph. All right, so I think pretty obviously we need to reflect this graph, right, horizontally to get it coming down instead of going up. So hopefully you see that pretty obviously. So let's reflect it over the y-axis. All right, so give that a try. See if it looks like this. Okay, so here we are just reflecting the graph over the y-axis, and we get this red graph here, and I've just kind of pushed these points over. So now we just got to think, all right, how do we get this graph now? It's facing kind of the right way, but how do we get it so that it's, instead of going through, say, 0, 1, it's going through 0, 5, and it looks like it's going through negative 1, 10. What kind of transformation would have you do that? Well, you might think that maybe it's a vertical shift, that maybe we just need to shift the graph up, say, 4 units. And that's a plausible thought, but remember now, you've still got this horizontal asymptote of y equals 0, and the graph we're striving for also has a horizontal asymptote. If we were to shift this graph up 4 units, that would mean our horizontal asymptote would also go up 4 units. It'd be up here at y equals 4, and that's not the case, right? So the fact that there's still this horizontal asymptote down here would suggest some kind of a stretch, all right? A vertical stretch, in fact, all right? So take a look at your points and see if you can figure out what factor would take this, from 0, 1 up to 0, 5, and then we've got negative 1, 2 up to negative 1, 10. All right, hopefully you're starting to already think about that. All right, why don't you pause the video, write your answer, and then check and see if you got this. What some people like to do first is write it just using the function notation, right? And so here's our reflection, putting a negative on the x, that's horizontal, and then we have our vertical stretch by a factor of 5, right? Because 2 times 5 will give us 10, 1 times 5 will give us 5. Keep in mind we're just multiplying the y values, right? The output values. All right, so what would that formula be in terms of x? Using the fact that f of x, the original function, the blue function, was 2 to the x. So see if you, hopefully you've already written this, but I'll write it now. There we go. We've got our formula here, 5 times 2 to the negative x, all right? And maybe you even went further and you wrote it as, 5 times, if you think about that, there's a negative 1 on that exponent, so this actually could be also written as 5 times 1/2 to the x power, right? Maybe put parentheses around that. There we go. All right, let's look at one more problem, and then there's a couple things to say in the book. This may surprise you, but it is actually possible for a vertical stretch to actually be the same thing as some kind of shift. So we're going to stretch this exponential function by a factor of 8, and your job is to figure out what kind of shift that is. All right. To get started, what I would do is let's just go ahead and write what the, let's tell you what, I'll call the new function f of x, and let's go ahead and write what the stretch by a factor of 8 would look like, right? So we just have 2 to the x, and stretching it vertically by a factor of 8, it's just going to be 8 times 2 to the x. So there's our function. The question is, can you make this look like a shift? And I'll tell you one other thing here. I chose that number 8 for a reason. All right, 8 has a relationship to 2. So if you can figure out that relationship, then I think you can probably figure out what the shift is going to be. All right, why don't you give that a try, pause the video, and then you can see if you got what I got. See if you got this. Okay, so hopefully you saw that, right, 8 is 2 cubed. And so if this is 2 cubed times 2 to the x, we have the same bases, and we rewrite as 2 to the 3 plus x. And now we're adding 3 to the x, and that gives us a shift, right? So we can just fill in up here that we have, we're going to shift it 3 units to the left, right? Because adding 3 to the x part means we're actually going left, the opposite way. That horizontal stuff is tricky. All right, well, let's take a look at the graph on the next slide and see that that is actually true here. Here we go. So here's our 2 to the x graph, and here's our 8 times 2 to the x, right? And you can see we are stretching it vertically by a factor of 8, because here we're going through 0, 1, here we're going through 0, 8, all right? But that's the same thing as simply shifting it left 3 units. Everywhere you look, you could shift it left 3 units and have the same graph. All right, I think that is really cool. Now this works for exponential functions, but may not work for other types. All right, got a couple other things just want to hit on, and then I will stop talking and let you do your homework. You may see a problem or two that talks about average rate of change or slope. So I wanted to go back to the first example on this sheet, and remember the original function was the blue, and the red was where we doubled it, right? We took 2 times f of x. And if you look, the blue graph has a slope of 1, right, or average rate of change of 1, and then over here -1. Well, hopefully, maybe you've already noticed this, but the slope of the red graph is actually 2, all right, up to and over and to the right 1, and then -2 over here. And then when we multiplied the original function by 1/2, you can see the slope now is also being multiplied by 1/2. Maybe a little harder to see this, but let's start at that point, right? We're going down 1 and then to the left 2, so that's got a slope of 1/2, and then here we're going to have a slope of -1/2. All right, so is that just a coincidence? It doesn't seem that way, so let's take a look just at some algebra really quickly. All right, so we have it all laid out here. So if we have some function g of x, which is some constant times f, all right, and we want to get the average rate of change of g, of course we're going to do g of b minus g of a over b minus a for some interval from a to b. All right, well, we can replace g of b, right? What is g of b? That would be k times f of b. So we have that here, and then we can replace the g of a with k times f of a. We still have all over b minus a. All right, and since both the terms in the numerator have a k value, we can factor that out, and that leaves us with just k times the quantity f of b minus f of a on top all over b minus a, and then that k can actually come out to the front, right? You can think of that as k over 1, and that'd be the same thing as just having k times your average rate of change right here, right? This is the average rate of change of f. So when you vertically stretch some function by a factor of k, you also change the average rate of change by that same factor. All right, and that might come up on a problem or two in the homework. It's not the most important thing in this chapter, but it's a nice little result. All right, the last thing I just want to say here is about number 40 on your homework. You can see, if we look at the instructions, we do have they say the point b is labeled. It's really the value b is labeled on the x-axis, and all they're asking us to do is on the y-axis locate and label the output values. They're not asking you to sketch another graph, okay? We are just going to label the y-axis with values. So for part A, we have the value f of b. Where does that go on the y-axis? first thing you might want to ask, is f of b going to be a positive or a negative number? Can you tell from the graph what it's going to be? All right, so why don't you contemplate that, pause the video, and see if you can figure out where exactly f of b would go on the y-axis. See if this is what you decided. Hopefully you figured out that f of b is a negative number, right? Because if that's b, then the point b f of b, given that this is f of x, is right here, and that means the output value, or the y value, will be right across from it, and that's where f of b is, all right? So you don't have to worry really about transformations in this problem. This is an input-output problem, trying to figure out where these numbers go on the y-axis, all right? Good luck with that, and good luck with the rest of the homework.